You start with 2, 3, 5, 7. Simple enough. Then 11, 13, 17. But as you count higher, the gaps between these numbers start to change. Sometimes they are clustered together, and sometimes they are separated by massive voids. These are prime numbers. A prime is a solitary figure. It only has two factors, the number 1 and itself. They cannot be broken down any further. That property makes them the absolute building blocks of arithmetic. Every other integer is constructed from a unique combination of primes, making them the literal atoms of mathematics. This chart shows how primes appear on the number line. As we count up to 1,000,000, you can see the count of primes rising in this jagged, irregular staircase. They get increasingly rare, and they completely ignore the smooth, predictive curve overlaying them. We expect mathematics to be precise and orderly, yet there is no formula that dictates exactly where the next prime will fall. To anyone counting, they look completely random. This structural unpredictability contradicts how mathematics is supposed to work. It forces us to ask why the numbers underlying universal order appear to be governed by chaos. In 1859, a German mathematician named Bernhard Riemann recognized that we would never decipher the sequence of primes by looking at them in a straight line. To find the pattern, he realized we have to abandon the traditional one-dimensional number line. We have to stretch our perspective upward and downward, expanding mathematics into a completely new two-dimensional space. This newly formed landscape is called the complex plane. Every single point here requires two coordinates, an ordinary real number on the horizontal axis and an imaginary number on the vertical axis. To navigate this landscape, Riemann used a specific equation called the zeta function. Think of it as a kind of mathematical sonar mapping the terrain. When you feed different complex coordinates into the zeta function, it spits out a new value, painting the plane with these swirling currents. Riemann noticed something distinct. At certain specific coordinates, the zeta function evaluates to exactly 0. These 0 points stand out clearly as distinct landmarks within the mathematical space. By stepping off the flat number line and looking from a higher dimension, we can finally observe structures that are completely invisible from the ground. And here is what Riemann discovered. All of these interesting 0 points, the non-trivial zeros, seem to fall in a perfectly straight line. They align precisely on a single vertical axis, right where the real coordinate is exactly 1/2. Riemann proved mathematically that these aligned zeros directly dictate the frequency and placement of prime numbers back on the ordinary number line. Every single 0 creates a mathematical wave that adjusts the distribution of primes. They act exactly like musical notes. When played together, this infinite chord of zeros orchestrates the primes, giving them their exact positions. The chaos we see in our dimension is an illusion. Prime numbers are actually distributed as tightly and regularly as mathematically possible, governed by an order hiding in plain sight. Today, proving that every 0 actually falls on this exact line is the most famous open problem in mathematics. The Clay Mathematics Institute lists it as a Millennium Prize problem, carrying a $1 million reward. Of the 7 problems on that list, only one has ever been solved, conquered by Grigori Perelman in 2003. The Riemann hypothesis remains completely open. Modern supercomputers have computed the first 10 trillion zeros of the zeta function. Every single one of those 10 trillion points lands precisely on Riemann's critical line, without a single exception. But in mathematics, 10 trillion pieces of evidence equals 0 proof. The number line goes on forever. Checking examples is useless when dealing with infinity, because we lack a logical argument that guarantees the pattern never breaks. David Hilbert, arguably the greatest mathematical mind of the 20th century, once said that if he were to sleep for 500 years, his very first question upon waking up would be, has the Riemann hypothesis been proved? The Riemann hypothesis marks a hard boundary of human knowledge. It shows us that there are universal truths we can clearly observe, yet we still lack the mathematical language to explain them.